Okay, so let's finish the second part of the Chapter 1 challenge problem of the intermediate algebra. So, question 40, we have two equations. We want to find all the pairs of x, y, right? So first is x cannot be equal to 0 and the y cannot be equal to 0. Okay. Now let's do it. So I want to deal with the integer. So we want to do the cross product on the first one. So we have the negative 24y minus the 36 of the x is equal to negative 7xy. Second one, we can have the 20 of the x, then 12 of the y plus equal to 25xy. So from the first one, I want to use the substitution. So I want to solve the y. So 24 plus the 7x times the y is equal to 36x. So we can solve the y is equal to 36x over 24 plus 7x. Okay, once we solve this, we are substituting to the second part. Let's move it a little bit. So 20x equal to 25x minus 12 times the y, right? Now let's substitute in the y is 36x and 24 plus 7x. So because x cannot be 0, right? So we can cancel the x on both sides. Now we can do it becomes a linear equation, right? So we can take out the 4 on here and 5. So the linear equation is 120 plus the 35x is equal to 25. 25 of the x minus the 108, right? So now let's further, we can solve it's 90 of the x is equal to 228. Then we can solve is the x is equal to the 190 is 19 times 10 is 19 times the 12, so it's 6 over 5. Okay, once you know the x is 6 over 5, right? Then we can substitute in here to solve the y, right? So y is equal to 36 times 6 over 5, then 24 plus 7, 6 over 5. So now you can see y is 4 over 3. Okay, so problem 41. Problem 41 is the Cramer's rule, right? So this has been covered in the Intro to Algebra, right? So you know the 1 and 2. To solve this one, we can define the dx equal to we can define the d is equal to the a, b, c, d, right? And it's equal to AD minus BC. Then dx, we replace the x term with the E and F and the BD. Then dy, we replace the y as the AC and EF. It's equal to the ED minus the BF is equal to the AF minus the E times C. So you know the x equal to the dx over d and the y equal to the dy over d. Okay. Oh, I won't talk too much about here. So we want to find some solutions of the K, right? Can linear system equation have no solutions, infinite solutions, and precise one solutions? So we can see the cyclic here, right? So k, when 1 is k plus 2, and k plus 2. So now let's see, the first is has no solutions. Let's add them together. So 1 plus 2 plus 3 is, we can have is k plus 2 of the x plus y plus z is equal to the 3k. So 1k is a negative 2, right? So with left side we have the 0 equal negative 6, so there is no solutions. So for B, if infinite solution, right? So for three variables, it's better to have three linear independent equations, right? We call the linear independent. So for three variable, we have three linear independent equations. We have unique solution, right? But if linear dependent, right? Let's say k equal 1, then all the equation becomes x plus y plus z equals 1. So in this case, you can pick anything, right? So that's why you have infinite solutions. Is k equals 1, right? For C means the k cannot equal to 1 and the k cannot equal to negative 2. Now we can solve it, right? From this 4, we know the x plus y plus z is equal to the 3k over the k plus 2, right? So if we apply to 1, you can see is the kx plus y plus z equal to k, right? So in this case, you can know the k minus 1 of the x equal to the k 1 minus 3 over k plus 2, then equal to the k times the k plus 2 and the k minus 1. K, because k doesn't equal to 1, right? So you know it's k over k plus 2. So it's by symmetry, you can see the x, y, z in this case is equal to k over k plus 2, k over k plus 2, and k over k plus 2. Yes, next. So question number 43 is let ABC be the non-zero constant. We want to solve this equation, okay? So what I want to solve it is I want to use the Gauss elimination process, use the matrix, okay? So we have the YZ, right? So B and AY equals C. Then we have the AZ, the 0 and A, and C equals B. Then the last one is B, C equals A. Okay, now let's do some elimination. The first is I want to eliminate this C. Okay, so in order to eliminate this C, the first row times the B, C over B, then plus the second row, right? So the first, let's copy BA0C here, and the last row doesn't change, 0C, B and A, and B times C, we could cancel this one, so the first becomes 0, then it's become negative AC over B, then the next is becomes still A, and is the C square over B, right? So it's the B over B square minus C square. Okay, then I want to cancel the A, right? I want to cancel this A. So now we apply to the last row, right? We want to cancel this A. We need to times the negative A over B of the last row applied to the plus the second row, right? The second row, yes. So it's the BA0 0c, and this 0cba. Now it's adding this one is 0, right? And this one becomes the negative AC, plus this is 2AC over B, right? And this one becomes the A minus A is 0. Then this one becomes the B of the B square minus the C square minus A square. Okay, so now you can see we only have on the second row, we only have the unknown of the y, right? So this 2ac over b times y is equal to the b over the b square minus c square minus a square. So we can solve the y is equal to the 2ac a square plus the c square minus the b square. Okay, so now we solve the y, right? Now the last question, you can see we have the c times y plus the b times z is equal to a, right? So we know the y, so we can solve the z, right? bz is equal to the a minus the 2a of the a square plus c square minus b square is equal to the 2a of the a square plus b square minus c square, right? So the z is equal to the 2ab, the a square plus b square minus c square. Okay, so from here you can kind of see the symmetry, right? So you can double verify x equal to the 2bc, right? So the b square plus the c square minus the a square. Okay, so by this case you can in this Gauss elimination process, okay, on the matrix, it's easy to solve it. So the final question is, we form in a row of a Pascal triangle, right? So we know the row of this one is 0 pick 0, right? Then 1 pick 0 and 1 pick 1, right? So the nth row is the n pick 0 to the n pick n, right? So now we have to have 3 consecutive entries occur that in ratio of 3, 4, 5. So we want to find which row, right? So we want to find n, right? In the nth row, there is a n pick I over the n pick I plus 1 over the n pick I plus 2 is equal to 3 to 4 to 5, right? So now let's do it. Okay, so the n pick I over n pick I plus 1 is equal to the n factorial I factorial n plus I factorial, right? Over the n factorial I plus 1 factorial, then n minus I minus 1 factorial is equal to the I plus 1, the n minus I equal to the 3 to the 4, right? And now we also can set up the second linear equation is ni plus 2, that is the n factorial I plus 1 factorial, the n minus I minus 1 factorial, n factorial I plus 2 factorial, n minus I minus 2 factorial is equal to the I plus 2 and the n minus I minus 1 is equal to the 4 over 5. Now you can see we have a linear equation, right, of the n and I, right? So here is we have the 4i plus 4 is equal to 3n minus 3i. So it's the 3n minus 7i is equal to 4. This one we have the 5i plus 10 is equal to 4n minus 4i minus 4. Then we have the 4n minus 9i is equal to 14. So we have the two equations. Okay, now we do the n, I, and the constant. So we have the 3 minus 7 and 4 and 4 negative 9 and 14. Okay, now we do Gauss elimination. Okay, so let's do that cancel out this one, so times the negative 4 over 3, right? So we have the 3 negative 7 and 4, then this one is 0, right? This one is 28 over 3, 28, yeah, so it's 1 over 3. This one is negative 14 over 3, negative 14 over 3. This is the 3 over 42 minus 3 over 16. So it is the 6 is 26 over 3. Okay, so from here, you can see we only have the unknown of the I, right? So means I equals 26. Once you know I equals 26, you apply to here. You can go solve n is equal to 62. So this is answer. Yeah, that's it for the chapter challenge problem of this chapter. Thank you. Bye bye.